Yes.
Okay. So today we'll discuss how to calculate correlation using SPSS. Okay.
Hmm.
And also I will discuss how to draw scatter diagram. Like I told you in the last class that I will discuss scatter diagram in details and
Hmm.
with correlation. So first I will discuss how to draw scatter diagram and how to interpret scatter diagram, and then I will discuss how to calculate correlation with SPSS. Okay. So before starting our class, uh, can you tell me what you know about correlation? Obviously, you know correlation, but I want to know how much you know or what is your idea about correlation.
As far as I know, it'll be like how one variable affects another variable. Like if there is an increase in one variable, will it affect the increase or decrease in another variable?
Okay. Okay. Anything else?
Uh, no, just along these lines.
Okay. So, yeah, you are right, but I will not say effect of one variable. Rather, I will say what is the relation between two variables or more than two
Yes,
variables.
yes, yes. Yeah,
Okay.
I'm sorry I got that. Yeah, I remember now they say that correlation is not causation.
Yes, exactly. So in correlation, we can say, okay, these two variables, they are related. Okay, or they are not related. But we cannot say, we cannot conclude that there is any cause and effect relationship. For that, we need other statistics. Okay. So
Hmm.
today, we'll start correlation, and these are the topic that I'm going to cover, like how to measure a relationship, how to enter data in correlation, and the most important things, bivariate correlation and partial correlation. Okay.
Hmm.
So I discussed that correlation means linear relationship between two variables. Okay. And we know that there are two type of correlation, positive and negative. Positive means when one variable increase, other variable also increase, means they are the variable they are changing in the same direction. And in case of negative correlation, the variables they move in the opposite direction. Okay. So
Hmm.
these things we know. There's another important concept that is called covariance. You have any idea what is covariance?
No, not covariance.
Okay. So covariance means suppose in a data in a distribution, there is a mean, right? And other
Hmm.
scores they are around mean, means we know the standard deviation which indicate the variability, means how much the spread of the score. Okay. So covariance means when there are two variables and they deviate from the mean in the same way, that is covariance. Okay, so
Hmm.
covariance is related to correlation, means if two variables they have similar kind of um, spread or similar kind of deviation from the mean, that is called covariance. Is it clear?
Yes.
Okay, so again there are two types of covariance: positive covariance and negative covariance. Positive covariance means they move in the same direction. It means if one variable is maybe it is in one variable, if the score they are below the mean, then the in other variable also the score they are uh, below the mean. Okay, similarly, but in negative covariance they move in the opposite direction. Is it
Hmm.
clear? Okay.
Yes.
So now we'll discuss how can we use scatter plot to express relationship between two variables. Okay. So scatter plot I discussed in the last class. It is a graph which show relationship between two variable. And if we use 3D scatter plot, we can explain relationship between three variables. So I will show you how to draw scatter plot as well as how to draw 3D scatter plot. Okay.
Hmm.
Also, there are different types of scatter plot like overlay matrix that I will also discuss. So suppose I want to know the relationship between exam anxiety and exam performance. Okay. So I can use scatter plot to express the relationship. Okay. So just let me discuss these two slides, then I will show you how to draw scatter plot. Okay. So why we need scatter plot? First, it will to tell us the relationship between two variables. So if we draw a scatter plot, we can know the relationship between two variables. That will give us some idea. Okay, and then after that we'll do the correlation. And also we can know the what kind of relationship they have, like it is a positive or it is negative, like this. Okay, and another very important thing, scatter plot help us to detect outliers. Like I discussed in the last class,
Hmm.
outliers are very important. We have to detect them. And scatterplot is a graph which helps us to detect outliers. Okay, obviously we'll use other graphs, but also scatterplot can help us to detect outliers. Okay, so there are two type of scatterplot. You can see this is positive scatterplot. It means increase in one variable also cause increase in other variable. May
Hmm.
not cause, mean when one variable increase, other variable also increase. So if the line is like this is called positive scatter plot. Okay, and this is negative scatter plot when increase in one variable uh, and while other variable decrease. When one variable is increasing, other one is decreasing. This is negative scatter plot. Okay, now the simple step. This step you know already we have discussed. So just let me open the now, I will import data from the Excel sheet. Okay. So these are the two variables. Variable one, fear of crime. I'm just writing fear here only. Okay. And second one is confidence in police. Okay. Now, if I want to draw a scatter plot, I have to go to graph. Then this one you know, still I'm showing you scatter
Hmm.
plot. Okay. So here you can see many options. Simple scatter plot, matrix, overlay, 3D. Okay. So first we will draw simple scatter. So in x-axis always you have to in x-axis there will be the predicted variable predictor. Okay.
Hmm.
So here confident in police is a predicting variable. Okay, if the confident if confident in police is high, then it is expected that the fear of crime will be low. This is expected. This is our hypothesis. Okay. So,
Hmm.
and in the y-axis, I will send the other variable. Here. So, the variable in x-axis, the predictor, and y-axis will send the other variable. Okay. So, now this is the options we have. Here we can, like, if we want to exclude any missing value and anything, if there is any missing value, we can also use this one. Okay. But we don't have, so we will just click continue, then click OK. Okay. So we have a scatter diagram. Now it is better if you draw a line here so that we can understand the nature. So just double click here, and this is the linear line.
Hmm.
Okay. So you can see
Hmm.
this is what kind of relationship we have.
The
This is a
negative one.
negative. Yes. So if the confidence is high, then the fear will be low. Okay. Just remember this one, like, also R square. I will discuss it a bit later. This is also very important one. Okay, I will discuss it but a bit later. So just clear now how to draw simple scatter diagram.
Yes.
Okay. Now, if I want to draw 3D scatter diagram, okay, just let me back to the slide. Okay, so this is the step. Now, the 3D scatter plot. 3D scatter plot basically it explains relationship between three variables. Okay, so suppose I want to know the relationship between exam anxiety and exam performance, and also the revision time. Okay, so my hypothesis is that if exam anxiety is high, then exam performance will be low. And if I give more time for revision, then my exam performance will be high. Okay, so we can easily draw a 3D scatter plot to explain the relationship. Just a minute. So, import data. Okay. Okay. One thing you can notice here, I don't have to change anything in the variable view. It is already there.
Okay.
Okay. Why? Because in the Excel sheet, I have no. When I enter data, I enter in exactly in the same in this way. So I
Oh,
don't have to add anything in the variable view. Okay, clear.
yes.
Okay, so these are the three variables. Okay, now I want to know relationship between these three variables. So I what I can do, I can draw a 3D scatter plot. The process is same: graph, legacy dialog, scatter diagram. Then click on 3D scatter plot and define. Okay, in x-axis we'll send exam anxiety, y-axis exam performance, and revision time in the z-axis. Okay, then click OK. You will get a scatter plot like this, but here you cannot draw this line like the previous one. Okay, here you can see with increase in revision time, there is increase in the exam performance. Okay, but for this particular data, it's better you draw other scatter plot that I will show you a bit later.
Hmm.
And this is exam anxiety with exam performance. Okay,
Hmm.
clear? So this is called 3D scatter plot. Any question?
No, no questions.
Okay. Next, we'll discuss overlay scatter plot. Okay. So, suppose you want to you want to see relationship between two variables. Three variables are there, but you want to see relationship between two variable and other and don't want to see the relationship between like you want to control another variable. Okay, so suppose you are interested to know the relation between exam anxiety and revision time on exam performance, but you don't want to see the relationship between exam anxiety and revision time. Okay, so in
Okay.
that case, you don't need to draw this one, because here also you don't want to know you don't want to see the relationship between these two variable. So better you just use overlay scatter plot. Okay, just let me show you, then it will be clear. So what we have to do, just go to graph, legacy dialog, and scatter plot. Okay, click here. So here you can see pair of variables. Okay, pairs are there. So I want to see the relation between exam anxiety. Exam anxiety will exam performance will be in the y-axis and anxiety in the x-axis. So here I can see the relation between performance and anxiety. Okay, and in the second pair, I will send revision exam performance again in the y-axis and exam revision time in the x-axis. But I don't want to see the relation between revision time and exam anxiety. So I don't need a third pair. Okay. Now simply click. So you will get two scatter plot. You can see two different colors are here. And now right click and draw the linear line. Okay. So these are the two different relationship you can see. The green line explain the relation between exam performance and revision time, which is positive, and the blue line represent the relation between exam performance and exam anxiety, which is negatively correlated. Is it clear?
Yes.
Okay. Clear? Any question?
No, no questions.
Okay. Okay. Now, suppose, just let me. Okay. Suppose there are many variables. Okay. Okay. So the last one that I will discuss is called matrix scatter plot. So there are many variables. Okay. Just let me transform the data. Sorry, import the data here. So, like, yeah. So we have five variables here. Okay. Zero pass, one fail. You can level anything here. I'm just doing it with pass and fail.
Hmm.
Okay. Now, in this case, if I draw a simple scatter plot, we have to draw many scatter plots. Okay, and if I draw pairwise, then we have to draw many pair. So it is better we use matrix. You can see in matrix scatter plot will be go to matrix scatter plot. Fine. These are the matrix variables. Okay. And click OK. So this is the thing. You can see relationship between like with every variable. Like here you can see the relationship between all the variables. Okay, like how A is related with E, how B is related with E, like this. Okay, so
Hmm.
we can simply double click and draw this one. And then we'll understand whether it is positive or negative or what kind of relationship they have. Okay, you can see.
Yes.
So it is much better than drawing several scatter plot, several simple scatter plots, right?
Hmm.
Or a 3D scatter plot is much better. So this is matrix scatter plot. Okay, any question?
No, so I just want to repeat, like, overlay scatter plot is like when there are three variables and you want the control to see which two to see the relationship of
Hmm.
two variables of your choice.
Hmm.
And matrix scatter plot is like when there are multiple variables and you want to see all the variables relationship with each other.
Yes, yes, yes.
Okay.
Overlay means when you are controlling other variable, or you if you don't want to know the relationship between two variables, you are just excluding those variables. Okay. But
Okay.
in matrix means you want to see relationship between all variables with each other. Like here, how A is related with E, how B is related with E. Okay. So if there are many variables, then it is better we draw this one. Okay, we'll have a clear picture. Clear? So
Yes.
whenever you are doing correlation, first you have to obviously you have to check the assumptions, okay,
Uh,
and you have to draw scatter plot. Even if you will know what kind of relationship you like from correlation, you will know that how the variables are related, whether they have positive relation, whether they are negative relation, and whether the relationship is significant. Everything you will know, but you need to draw a graph because graph is always no like it is good if you draw a graph and explain support your result. Okay, so and in correlation we'll draw use only scatter plot. Okay,
okay.
clear? Okay.
Yes.
Now we'll discuss um, the correlation. Okay, so there are two types of correlation: bivariate and partial. Any idea what is bivariate and what is partial correlation?
No.
Okay. But can you tell me some correlation, means some types of correlation or names of correlation?
Like, I know there is positive and negative.
These are the types, but the different you don't know Pearson, Spearman, Kendall,
No,
Bivariate,
no.
Biserial,
Even in that, I just know spearmen and this thing only.
Spearman, and
Yeah.
Pearson.
Yeah.
Okay, okay. No problem. Bivariate correlation means this is correlation between simply correlation between two variables. Like if I want to know whether there is a relation between exam performance and exam anxiety, that is bivariate correlation. Okay.
Mm.
Partial correlation means when we want to control other variables. Okay, so there is relationship between we know there is a relationship between exam anxiety and exam performance, right? But other
Mm.
factors which can also affect exam performance, like how much like revision time or maybe intelligence of the student. Okay, so when we want to control all these variable and just want to see relationship between two variable, that is called partial correlation. Okay, so it can happen that you are controlling only one variable, that is called first order partial correlation. Now, if you are controlling two variables, that is called second order correlation. Sorry, second order partial correlation. Okay, So if you are controlling two, three variable, that is called third order partial correlation. So the difference is that in bivariate correlation, you are not controlling anything. You are just want to see whether there is relationship between two variables or not. In partial correlation, you are controlling other factors which may have effect on the relationship, or which may have effect on one of the variables. Okay, is it clear?
Yes.
Okay. So first we'll discuss bivariate correlation. Under bivariate correlation, we'll discuss Pearson product moment, Spearman, biserial, point biserial, and Kendall. Okay.
Okay.
Okay. Pearson product moment correlation is the most popular correlation. And one thing you have to remember, this is a parametric correlation. So whenever, if your data fulfill the assumption of parametric, like we discussed in the last class, okay, then only you can use Pearson. And if your data don't fulfill the assumptions or violate the assumption, then you have to use Spearman or Kendall. Okay.
Okay.
So Pearson, even if I'm telling you from my personal experience, when I was analyzing my PhD data, I have to do a correlation where the n was 80. Okay, so for 80 we can easily use Pearson. We don't have to use Spearman. But when I check the assumption, the data violated the assumptions. Okay, it was not normally distributed. It was not homogeneous. So I have to use Spearman. Okay, so it is very important you check the nature of your data before using Pearson product model. Okay,
Hmm.
so in Pearson product moment, one important assumption is that the variables, both variables are normally distributed. Okay, and we can use Pearson product moment correlation when the score are on interval scale. Okay, clear?
Hmm.
So how we can use, these are the step. Okay, let me show you. Uh, so this is the first variable here. Now go to analyze, then go to correlate. Okay, you can see here correlate and then bivariate.
Hmm.
Okay, peer and confidence. Okay, you can see three options are here. This is by default, it is Pearson, so you don't have to change anything here. Okay,
Hmm.
then go to option. Here you will get, you can get mean and standard deviation. If you want to know the covariance, also you can click here. Okay, and if there is any missing value, then you have to click here. Okay, but we don't have, so I'm not doing anything. Just right, continue. Then click OK. So you can see this is the table. These are the mean and ST, and this is the correlation table. It is clearly written here. It is significant at 0.01 level. So basically, you don't have to do anything in this table. You will just, if you click, you will get your score. Okay,
Okay.
clear. It is very easy. Correlations are very easy. Is it clear now? What you have to
Yes.
do? Okay.
Yes.
Okay. Okay. Before that, you have to check. I forgot to check the distribution. We have to do that. Just a minute. So how we are going to do that? How we are going to check the assumptions? What we have to do?
Okay. I'm sorry, I don't remember right now, and I don't have my notes with me.
Okay.
I know. No, no, I don't have the notes with me.
Fear and confidence. Okay. Then okay. This is normality test,
Hmm.
and then continue. Okay. So you can see this is significant. Okay.
Hmm.
So actually we cannot use Pearson here because this significant means uh, This like in case of fear it is significant, in case of confidence this is not significant, but still it is significant, so we cannot use Pearson here because data is not normally distributed, right? And in same way we can go to um, so, okay, it is not transform, untransformed data. So continue. Okay, this is the box plot we have. We don't have any outlier here. Just a formality. Okay, this is the box plot we have.
Yes.
Okay, so we don't have any outlier here, but still we cannot use Pearson because the data does not fulfill the assumption of normality. Okay, clear? Okay.
Yes.
Now, so clear. This is Pearson product moment correlation. Okay, just I'm showing you the step. So in this way you have to do, but before doing Pearson, you have to check the assumption it is fulfilled or not. Okay. So this is the example that I just show you. So I'm not discussing it here. Now, if our data, okay, one more thing. Okay, how can we use R square for interpretation? So when I draw the scatter diagram, I show you that there is a score called R square. Just let me draw a graph. Then
Yeah, it was on the upper corner.
yes, this one. So I'm drawing simple scatter plot. Yes. Okay. So here we can see this R square. Okay. R square basically it is the square. It is called the correlation coefficient square. Okay. So it from correlation we cannot say cause and effect relationship, but we can say how much how much one variable is responsible for changing other variable. Okay. So like this is the R square we have. So if we multiply it with 100, okay, then we'll get a score, okay, 8.1% for this one. Okay, so we can say that 8.1 like fear 8 we can say in case of this variable we can say that fear sorry we have exam sorry confident in police is 8% responsible for the fear of crime.
Here.
Okay. So there is some cause and effect relationship, and in 8% of the cases, we can say that confidence is police is related to fear of crime. Okay, and obviously this is a negative correlation. It means if we have more confidence in police, then our fear of crime will be low, and it is responsible in the 8% of the cases, 8.1% of the cases. Okay, clear. So R square is very important thing which can help us to explain some amount of causality. But yes, we cannot say causative relationship like t-test or ANOVA, but we can predict some relationship from this R square. Is it clear?
Yes, yes, it
Okay.
is.
So in SPSS, we don't have to calculate it separately. We already have it here. We just have to multiply it with 100. Then we'll get the percentage. Okay, fine?
You said we have to multiply it by 100.
Yes, yes. Into 100. Clear? Okay.
Yes.
Now, next we'll discuss Spearman. Okay, Spearman correlation is non-parametric statistics. Okay, and it is used, we know, when the data violated the parametric assumption and when the data is in ordinal scale. As we know, it is a rank correlation. In Spearman, we rank the score. If you remember, when we are not using SPSS, we are doing it manually. We rank the score, right? And we use a rank to see the correlation. Okay, so if you remember,
Yes.
uh, yes or no? If no, then no problem. I will show you. Okay, just
Yeah. If you can show me, that would be better. Since
yeah,
I
I will.
don't have my notes today, it's a little disorienting for me as well.
Okay, okay. So suppose I want to see the relationship between marks in history and marks in geography. Okay, so okay, first let me. Okay, so let me import the data. Now, if we use Spearman, if we do Spearman manually, what we'll do, we'll give rank. Like highest score will get 1, then the next highest score will get 2. Okay, similarly, in for this variable also, we will use the rank and we'll see the correlation between these two rank. Right. So, in case of Spearman correlation, always the score they are in ordinal scale or in a order. Okay. So, is it clear?
Yes.
Okay. Okay. So what are the steps? Just you have to analyze, same way, analyze, bivariate, sorry, correlate, then go to bivariate with the sentence here in this side. Okay. We have option mean continue, and here mention one tail test, change it to one tail test. Okay. And then click. Oh,
Can
sorry. You
you
have to.
tell me when to choose two-tailed and when to choose one-tailed?
Okay. Uh, in case of just a minute to deactivate them. Okay. Uh, one tail test means it is giving you direction as well as the score. Okay. So in case of Spearman, always choose one tail test. Just remember this, and other in case of Pearson and Kendall, it is by default two tail. You don't have to do anything. Okay. Just in case of Spearman, choose one tail test. Okay.
Okay.
Okay. Now, you have to change here. I've just forgot to change here. You have to. It is always Pearson by default. You have to change it to Spearman. Okay. Then click OK. Fine. So this is the score we have, and it is clearly mentioned that it is significant at 0.05 level. Clear?
Yes.
And you can see it is written non-parametric correlation. Clear?
Yes.
Okay. I have mentioned here so it you would, so that you can remember until a total. Okay. Similarly, another test is another non-parametric test is Kendall. Okay, in Kendall test, what we do that similarly we check the rank. Okay, but in Kendall test, generally we use if it is a small data set, and second if there is many tied rank. Tied rank means same rank. Maybe same scores are there, and we have to rank them. We have to give them similar rank. In that case, we use Kendall. Is it clear?
No, just give me a moment. Yes, got it.
Okay. Uh, So just let me show you. Suppose in this case, uh, many maybe there are two or three 45s are there, score 45. Okay.
Hmm.
So in that case, you have to give them similar rank, same rank. Okay. Maybe all of them will get rank 5. Okay. So in that case, we say they have tied rank, means similar rank. In that case, we'll use Kendall. So there are two conditions when we use Kendall test. First, if the data is small, okay, and if there is many tied rank, similar kind of rank. Is it clear?
Yes.
Okay. Now, uh, just if I want to do the Kendall test here, what I will do? These are the steps. Same step we have to do. We have to go through. Okay. Uh, just go to analyze, correlate, bivariate. So just change it to Kendall. Okay, and click OK. So you can see here also it is non-parametric and written that it is significant at 0.05 level. Clear? Clear? Any
Yeah.
question?
No questions.
Okay, fine. Now, next we'll discuss point biserial and biserial. Okay, you have any idea about point biserial or biserial and point biserial and biserial correlation?
No, ma'am.
No idea. Okay. Point biserial and biserial correlation, they are not so much popular like Pearson and Spearman. Okay. But we use them in certain cases. Like suppose you want to see relationship between two variable. One variable is continuous variable. And another variable is dichotomous variable, which is a genuine dichotomous. Genuine dichotomous means there is no underlying continuity, like male or female. Okay, or pregnant or non-pregnant, like if maybe someone is pregnant or maybe someone is non-pregnant, but there is nothing called in between, right? Or dead or alive, there is nothing called half dead. Okay, we use many times, but that is the different thing. But if we say scientifically, there is nothing called in between, either dead or alive, either pregnant or non-pregnant, right?
Hmm.
Male and female is there is third gender, but that is it's not like that, but still it is categorical, genuinely dichotomous. It's not like that it is a there is a underlying continuity. Okay,
Okay.
so in case of two, if the two variables, one variable is continuous variable, another variable is genuinely dichotomous variable, we use point biserial correlation. Okay, like suppose test score between x and test of y, where y is right and wrong. Okay, so if either the answer is right or wrong, we cannot say that there is something in between right and wrong. Okay, maybe objective type questions are there. Either the answer is right or it is wrong. It is not like that there is something in between. So this is genuine dichotomous. So in that case, we'll use point biserial. That case we'll use point biserial correlation. Is it clear? What is genuine
Yes.
dichotomous?
Yes,
So
ma'am.
one variable is there which is continuous, another one is dichotomous. Okay, but in point biserial correlation, like in SPSS, there is no separate option for point biserial. We have to calculate Pearson correlation. Okay, but we'll get the result of point biserial. How, that I'm showing you. Okay, so input data. So this is test score of x, and this is test score of y. Okay. Now I have written here 0 means pass and 1 means fail. For my own understanding, you can delete this one. Mhm. Okay. Now we can go to the here. We have to change the values. 0, sorry, 0, fail. Mhm. Sorry, not pass fail. So, pass fail is not genuinely dichotomous. Right and wrong. Pass. Okay. I have to change. 0 is right and 1 is wrong. Okay. Here, right and wrong is genuine dichotomous, but pass fail is not. Why not? I will discuss a bit later. So here you can see we are comparing these two variables. So the first variable is a continuous variable, the score of test x, and the second variable, this is a categorical variable. We are comparing compare we are see the correlation between this continuous score and this categorical score. Okay, is it clear?
Yes.
Okay. Now we will go to simply to analyze, correlate, bivariate, and send the variable in this side. Okay. It is by default is Pearson and total, so we will have to change anything. We need mean and standard deviation. Just click here, continue, and okay. So you can see there is negative correlation. Okay, this is negative correlation and it is not significant. Clear? So you say, ma'am, we are doing Pearson, but bivariate correlation when we do in SPSS, we do it with Pearson. But here we are not comparing two continuous score. Sorry, no, we are not correlating two continuous score. Rather, we are seeing the correlation between one continuous score and one categorical score. Is it clear?
Huh.
Okay. So, but we also have to draw scatter diagram. So scatter plot. We'll do simple scatter plot here. We'll send this one on x-axis and this one on y-axis. We'll send the categorical variable on x-axis and the continuous variable on y-axis, and then click OK. This is the scatter plot we have. Then so what kind of relationship they have? Here 0 means wrong answer and 1 means right answer. Okay. So as we are moving from wrong to right answer, the score
Negative.
of x is
Decreasing.
decreasing. So they have negative correlation. Also, we can see here they have negative correlation, but this is not significant.
Hmm.
And we have r square here, which we can see how much it is responsible. Okay, is it clear?
Yes, ma'am.
Okay. Any question?
No, no. No questions.
Okay, fine. Now, there's another one called biserial. Now, in case of biserial correlation, here also there are two type of variable. One is continuous variable, another one is dichotomous variable. But here the dichotomous variable is not genuine; it is artificial. Like they have point, but this point is not like this is the point we have decided as per our own convenience. Okay, like so it is called artificial, like pass and fail. Okay, so I have decided, okay, the students who are like whose score is below 50%, they are fail. Okay, and the score who is above 50%, they are pass. Okay, but if I decide the 30% is the cutoff mark, also I can do that. If I decide, okay, 75% is the cutoff mark, also I can do that. So we cannot say they are genuinely dichotomous. They are dichotomous, but that is artificial. Means they have an underlying continuity. Is it clear?
Yes.
So, an example like pass and fail or socially adjusted, socially maladjusted. They are not genuinely dichotomous. Maybe something is socially maladjusted. I think that is not socially approved. You think that is socially approved. Okay, like we have many things like let's suppose gay marriage. I think it is not socially acceptable. You think it is socially acceptable. So for me, if someone is homosexual, I think the person is not normal. But you think okay, the person is normal. Okay, so it is not. We cannot say that they have genuine gap. Okay, so athletic, non-athletic. These are example of artificial dichotomies. Clear? So in that case, we'll use biserial correlation. Any question?
No.
So this okay. In SPSS again, we don't have any option for biserial correlation. We have to calculate through Pearson, and first we have to calculate point biserial, and then we have to make an adjustment by this equation. Okay, so this is the equation. Here R This is RPB. RPB means a point biserial correlation. So first you have to calculate point biserial in SPSS, then you will get a score. And then P1 means the proportion of the case that fall into the category 1. Okay, means in the maybe the first category is pass and second category is fail. So in the category 1 is the proportion of the cases in the category 1, and P2 is the proportion of the cases in the category 2, and Y means the ordinate where we can divide this 2. Okay, so we'll get the score of Y from any book. There is a in appendix you'll find a table called table for standard normal distribution. Okay, this is a table. This is the Y ordinate. Clear?
Hmm.
So in this the two sides we have two scores, that is genuinely dichotomous. They are genuinely dichotomous. Artificially dichotomous score of two variables, two categories, and from this Z score you will get the value of Y here. Large portion, smaller portion, and value of Y. Okay,
Okay.
clear. So if for this you don't have to you don't have to remember anything. You will get this from this table. Fine. Now, how will calculate P and P2? For we have to calculate the frequency. So let me show you in the SPSS datasheet. Transform. Sorry. Input data. Excel. Uh, the achievement test and arithmetic test. So here we can see uh, this achievement test. And this one you can okay, you have to put the values 1. Yes. So again we can see here we are comparing two variable. One is continuous variable, another one is artificially dichotomous variable, pass and fill. Now we have to go to analyze. Okay, first we have to draw a scatter diagram. So go to graph, legacy dialog, scatter diagram, simple scatter plot, define. So what kind of relationship we have? Zero
Positive.
means zero means fail and one means pass. It means like students who like we are moving. If we move from 0 to 1, the score of achievement is also increase,
Increasing.
and they have positive
Positive.
relationship. Also, we have here the R square, which can explain again. It is 8.18 percentage. Okay. Now we will calculate the biserial point biserial. Biserial we have to do, sorry, by point biserial we have to do here, then we'll calculate biserial from there. So go to the correlate, bivariate, and you don't have to change anything, just you have to take million SP. Okay. So this is the correlation. Okay, we have biserial correlation and we need frequency to know P1 and P2. So go to analyze, let's go to statistics and frequency. So so here we have frequency. You can see that 50% is for P1 and 50% P2. Okay. Now you have all the things. Now you have simply you have to calculate data using, sorry, you have to use this formula and you have to calculate RB. Okay. Yeah. And we
Hmm.
can see it is significant from the biserial correlation. Clear?
Yes.
Okay. Now, any question? So these are all bivariate correlation where we check relationship between two variables. Okay.
Hmm.
Now we'll discuss partial correlation. Okay. Now, in case of partial correlation, we control other variable. Okay. So, if I want to study the relationship between exam anxiety and exam performance, and there is another factor revision time, and we don't want to say which can affect the relationship we know, so we can control revision time, and we can see the effect of this two relation between these two variables. Okay. So, what we have to do? uh, Import data. Now, first you have to draw a graph. Now, in this case, which graph you think is suitable?
Hmm. What about the matrix scatter? I mean, it's showing it has different places for. Is it for different variables?
Okay. Just tell me one thing. It is we are doing partial correlation. So we are not interested to know the effect of revision time. We are just want to we know that revision time can have
Yeah,
effect on.
yeah. It's overlay scatter.
Yes. So you have to know your objective. Okay.
Hmm.
So exam performance, exam anxiety will be in the y-axis, and no, exam anxiety is in the x-axis. Performance in the y-axis, and anxiety in the x-axis. Okay. And then click OK and get data here. So this is the code we have here, right? Negative correlation. Okay. Now we have to go to analyze, then correlate and partial. Okay. So here you have to send this to score under variable exam performance, exam anxiety, and revision time in controlling form. Okay. We have option here, the mean and standard deviation. Another thing is zero order correlation. Zero order correlation means the bivariate correlation. Okay.
Okay.
So in case of zero order correlation, we are not controlling any variable. So if we click here, we'll also get the score of bivariate correlation. Okay, without any control. Then click OK. Fine.
Hmm.
So this is the score we have. Sorry. First, let me explain this table. This is a partial correlation. Sorry, this is the table. So control variable, when we are controlling the variable, here we are not controlling any variable, so it is written none. You can see these are the correlation values. Okay, and this is the time when we are using the partial correlation. We are controlling revision time. Okay,
Hmm.
so these are the correlation value, and no one is significant. You can see it is written cell A contains zero order Pearson correlation.
Huh.
Okay. So we have all the kind of data and we can use it for interpretation, and it is a negative correlation. Okay.
Hmm.
Clear?
Yes.
Okay. So, for what are the steps of correlation? First, you have to import your data. Then you have to write all the variable. And if you have enter your data, like in your Excel sheet, you have already mentioned the variable. Then you can see it is automatically it will be there, so you don't have to do anything. Just if there is any value, you have to change that. Okay. Then you have to check the assumptions if they are if the data fulfill the assumptions or they are not fulfilling the assumption, and then you have to decide what kind of statistics you are going to use, either Pearson or Kendall or Spearman. Okay, and then if there is both variables are continuous, then you can use Pearson. If one variable is continuous, one variable is dichotomous, you have to see whether they are genuine dichotomous or they are artificial dichotomous. In case of genuine dichotomous, you will use point biserial, and in case of artificial dichotomous, you will use biserial, right?
Okay.
Then you have to draw the scatter plot. Scatter plot will give you idea about the relationship, whether they are positive or negative. Okay,
Hmm.
or the value of r square means how much variable can explain the other variable. Okay, then
Huh.
you will do the correlation, and then and after the doing correlation, you will get the data. You don't have to do anything separately. Only in case of point biserial, you have to calculate by using the formula. Otherwise, you will get the data whether it is significant or not. Everything is mentioned there. Okay, these are the steps. Any
Okay.
question?
No, no questions.
Okay. So, do you think correlation is it is very easy, right?
Yeah, it seems easy.
It's very easy. SPSS is very easy. Initially you are doing classes back to back. Initially, it's like okay, it's very difficult, but once you understand it, it is very easy. And obviously, you have to practice. That is very
Hmm.
important. Okay, the more you practice, the more you will understand. More you will know, will better remember how to do the thing. But SPSS is very easy. I feel that very easy. Okay, any
Okay.
question?
No, no questions as of now.
Okay. So next tomorrow we'll discuss t-test. Okay.